In this video, we're going to begin our discussion with tests for independence and homogeneity of proportions. So in this section, we will develop methods for performing statistical inference on two categorical variables to determine whether a parent association between the two variables is statistically significant. And we will use this chi-squared test for independence. And this chi-squared test for independence is used to determine if there's an association between the row variable and a column variable in a contingency table constructed from sample data. The null hypothesis is that the variables are not associated, or in other words, they are independent of each other. The alternative hypothesis says that the variables are associated or dependent. The idea behind testing these types of claims is to compare actual counts to the counts we would expect if the null hypothesis were true. In other words, the variables are independent. If a significant difference between the actual counts and expected counts exist, we would take this as evidence against the null hypothesis. So, to obtain these expected counts, compute the row and column totals, compute the relative marginal frequencies for the row and column variable, use the multiplication rule for independent events to compute the expected proportions of observations within each cell, assuming independence. So remember, the probability of E and F would be the probability of E times the probability of F. Multiply the proportions by the sample size. So I've done this example to help with the expected counts. So originally the data is in 2 rows and 3 columns. In other words, a 2 by 3 here. I've done every column total, every row total, and I've done all the relative frequencies for each column and for each row. So the expected proportion of each cell, let's just take a look at one, men and money. It would be the relative frequency for the column times the relative frequency for the row, and we get this particular decimal. The last part I would do then is to take the sample total, 1776, and multiply by the decimal appropriately. And we get the approximation in this case is 63.639. And you can do this for every single cell here. So at this particular stage, this is a lot of work to be able to do this. Is there a shortcut to do this? And the answer is yes. We'll use what is called expected frequencies in a chi-squared test for independence. So to calculate the expected frequency in a cell when performing a chi-square independence test, multiply the cell's row total by its column total and divide by this result by the table total. And I've given the expected frequency formula below. And I've done a quick example with doing both women and love. So this was the total number of women times the total number of people that chose love divided by the total number in the sample. Now, there is good news. You won't have to calculate these expected frequencies by hand. The calculator will do the work for you, and I'll show you how to do this later on. Okay, chi-square test for independence. Right. To test the association between two variables in a contingency table, we perform the following steps. Number 1, determine the null and alternative hypotheses. So again, the null hypothesis, the variables would be independent. Alternative hypotheses, the variables would be dependent. Right? They'll give you the level of significance for alpha and perform the test. We want to calculate the expected frequencies for each cell in a contingency table. With that, we need to verify that the requirements for the chi-square test for independence are satisfied. And they look almost identical to the goodness of fit requirements we talked about earlier. If the p-value is less than alpha, we will reject the null hypothesis. So note, the chi-square test for independence uses the same test statistic as the goodness of fit. Okay, let's take a look at an example. So we already started this, the 883 males and 893 females, and they have one of the following to choose. Right? We want to be able to test the claim that the gender and response are independent using alpha equal to 0.05 level of significance. Well, the first thing we need to do is to identify what the expected frequencies are going to be. Well, we did that on the previous page, so I have that listed below. Now that we have the expected frequencies, we now need to make sure the requirements have been met. So what is that? All the expected frequencies are greater than or equal to 1. That's the case in green here. And none of the expected frequencies are less than 5. So there are the conditions written out. Now that the conditions have been written out, we need to write out the null and the alternative hypotheses. So I'm going to write those out now. So the null hypothesis is gender and responses are independent or not related, and the alternative hypothesis is gender and responses are dependent. Okay, so let's perform our test in the calculator now. So before we can do the test, we must put our data into some sort of table form, which is called a matrix. Well, you can certainly do matrices in the calculator. Well, how do I do that? Hit the second, and then it's x to the negative first, which is 3 buttons down, and you should also be able to see in blue the word matrix. So we're going to edit, hit enter. Now, in our table, it was a 2 rows, hit enter, and 3 columns. And you would type in each data value, hit enter. Type another data value in, hit enter, until you fill out the entire table for this. Once that's done, hit second and mode to exit. So now that we have the matrix into the calculator, now we need to do the statistical test here. So hit stat, highlight tests, and we're going to go to letter C. That's going to be chi-squared test. Hit enter. The observed matrix is A. The expected will be B. That's fine. Highlight, calculate, and hit enter. So our p-value is given here. Now, just as an FYI now, you're probably wondering, well, we didn't even put the expected frequencies into the calculator. Well, when you perform the test, matrix B is going to automatically be the expected frequency matrix. Well, let's check that. Hit second, and again, x to the negative first, which is matrix. Go down to matrix B and hit edit. And those particular values are all correct, rounded to 2 decimal places. Okay, now let's write this on the paper. So you would write chi-squared test, right parenthesis, brace A, that's matrix A, remember that's the original data values, and then comma, braces B, that's the expected frequency matrix, and I've written out the p-value. Clearly the p-value is less than the error at this stage, so we will reject the null hypothesis. So let's write the conclusion out now. There seems to be sufficient evidence at the alpha equal to 0.05 level of significance to conclude that gender and a person's response is dependent and not independent.